Hi everyone. In today's video, I'm going to discuss about the topic knowledge graph. Many AI applications were using knowledge graph to build applications like recommendation systems, search engines and AI assistants. So what is knowledge graph? Before getting into the details, let's try these questions. I will give you a few sentences with a missing word. Can you try to fill the missing words? You can easily fill the proper word in the missing areas. So how did you fill the correct words here? You used your mind, which is your knowledge graph. You know how each word is related to each other and which word fit in the missing area. You already know how the word Einstein is related to the theory of relativity and how the word Eiffel Tower is related to Paris. Basically, you can connect the related words and fill the accurate word. Knowledge graph is also similar to this. In a knowledge graph, data or the knowledge can be represented as the graph. This is a simple visual representation of a basic knowledge graph. In this graph, the word Apple is connected to Steve Jobs because there is a relation between the words. Similarly, the words Apple and iPhone are connected, and the words Steve Jobs and California is connected. This is a very simple knowledge graph with minimal data. We can build knowledge graph with millions or trillions of data points with relations. There are few terminologies that we need to understand in knowledge graph, that are entities, relationship, rules. Entity, also called node, represents an object that can be a person's name, place or any other object. In the above example, Steve Jobs, California, Apple, etc. are the entities which is also called nodes. So basically, Steve Jobs is a node, California is a node, Apple is another node. Next term is relationship, which is also called edge. In this example, the word founded by is the edge between Apple and Steve Jobs. The word created is the edge between Apple and iPhone. So nodes have relation with each other using edges. Next term is ontology. An ontology defines the structure, relationships and meaning of the data within the graph. It serves as a formal schema or blueprint that organizes information in a way that machines can understand and reason about. Basically, ontology defines rules and constraints. Consider a knowledge graph for a business domain. An entity called customer can have attributes like name, email, phone number, etc. And another entity called product can have attributes like product name, price, etc. But the customer does not keep the attributes like product name or price. Using ontology, we can define these rules and constraints. Basically, ontology is a standardization. Entities, relationship, ontology. These are the basic terms that we need to understand in knowledge graph. So in definition, knowledge graph is a structured data model that represent real world entities like people, place, objects and their relationship as a network of nodes connected by edges. Now you understand what is knowledge graph. So how we can store this data? Is there any specific database available for this? We can use graph databases for this. Using graph database, we can store and retrieve these data. Some of the graph databases that are available are Neo4j, Amazon Neptune, ArangoDB, OrientDB, etc. Graph database like Neo4j use cipher query language. It uses this language to traverse through the nodes to return the result. For example, if you write a query like find all friends of Alice's friends, in Neo4j's language, which is cipher language, it looks like this. First, it checks if your query makes sense, means there is no typos, the query has valid labels like person, etc. First, it finds Alice using her name, then follow her friend relationships to her friends. From each friend, follow their friend relationships, and finally returns those names. Instead of combining tables, Neo4j jumps directly from Alice to her friends, then to their friends. In a relational database, finding friends of friends would require joining multiple tables, which gets slow for deep connections. Graph database skips the joins and follow the links instead. Think of graph database as a GPS for relationships. It already knows the roads, which is the connections between the cities, which is the data points. So it can navigate faster than a database that has to build the map every time. So it already have the map, it only need to find the best route. Knowledge graph bridges the gap between unstructured data and machine interpretable knowledge, making AI systems more intelligent, adaptive, and trustworthy. They are foundational for applications requiring deep contextual awareness, from healthcare to finance, and will remain critical as AI advances toward more human-like reasoning. So that's all about today's video. If you found this helpful, please consider to subscribe and like the video. Thank you for watching and see you in the next video. Bye.